Proportional relationships. So here we're given two tables. We have data for family Z and for family A. We're comparing the time in hours versus the distance in miles from their home. So let's complete the items for each table. Let's find the slope of each table, the y-intercept for each table, and then if we have both those values, we'll be able to write the equation of the table in slope-intercept form. Well, the slope of the first table is going to be 70 over 1. You have your change in y is going to be 210 over 3, or the same as 140 over 2. That's where we get 70 over 1. Both simplify to 70 over 1. The y-intercept is 0 from this data point of 0, 0. So the equation for this table is y equals 70x. There's your mx plus b. It's technically 70x plus 0, but we don't have to see that 0. Now for the table for family A, we have the same slope of 70. So again, we're looking at the values of the change in y of 210 over 3, or 140 over the change in x of 2. So again, both simplify to 70 over 1. But now this table has a y-intercept b of 10 from 0, 10, that data point. So we get the equation of y equals 70x plus 10. If this data from both tables were graphed on the same coordinate plane, what would you notice? Well, you should see that they both have the same slopes. They have the same slope of 70 over 1, but both equations are starting at different y-intercepts. Family Z's equation would be starting at the origin, versus family A's would be starting up at 10. So you see you have an equation that goes through the origin with the slope versus an equation that has almost been translated up to that 10 and then has the same slope. So they would have the same graph just in different spots. You can think different places on the coordinate plane. We're going to take a closer look at the data from family Z, where you have this equation of y equals 70x, and the y-intercept is going through and is the origin. That was an example of something called a proportional relationship. A proportional relationship is a relationship in which the ratios of related terms are equal. Linear equations that have a proportional relationship are known as direct variation equations, which take the form of y equals mx. So the graph to the right here, this is an example of a direct variation. This equation is y equals 2x. The proportional relationship is expressed in the slope and the ratio of every y-coordinate to every x-coordinate, with the exception of the origin. Why do you think the proportional relationship is not shown with the origin? Think of the difference in random xy points on your line, such as an example of this line. You have 3 and 6, 1 and 2, -2 and -4, versus that origin. Think, what are the coordinates of the origin? The coordinates of the origin are 0, 0, so what would be the ratio of that y-coordinate to that x-coordinate? Why would that be a problem? Well, the proportional relationship is not shown in the origin because the ratio of 0, 0 is a problem. It's not a real number. So that's why we have to include that in the definition, that it works for every other point or ordered pair on your line except for the origin. We have to exclude that 0, 0 ratio. Now we can see the proportional relationship given a graph and then write the equation of the graph using that relationship. So here we have an example. We have a line, and we can see the proportional relationship is 3 over 4. We can see that from the slope. We can see that by going up 3, right 4, up 3, right 4. Or if we take an ordered pair on that graph, for example, we have the ordered pair of 4, 3, we can see it's that ratio of the y over x. It's that ratio in the ordered pair. So the equation of this line, if we take that 3 over 4, is going to give us the equation y equals 3/4 x. So the slope is 3/4, but the ordered pair, if you look at the ratio of y to x, that is the 3 over 4. But you can also have your ratio of 4 to 3 will be the same as the ratio of, let's say, this ordered pair here, where you have -4, -3. So that ratio of x to y is the same as the ratio of 4 to 3 here, this x to y. It will be the same for all of those points on the line. We can also see proportional relationships in a table. If we look again at the slope, we can look and use the change in y over the change in x in the table. Here we have our change in y is +5. You're adding 5 each time. And here we have a change in x is -3. So you can use the proportional relationship as 5 over -3 or -5/3. So then what is the equation? We would have y equals that proportional relationship, -5/3, which is also the slope, and we have that times x. And we can check our work here. Again, we have -5 over 3, and the equation is -5 over 3x. So the proportional relationship is equal to the slope of the line, and the line is always passing through the origin, 0, 0. And the ratios of the x to y values will always be the same, except for that point of 0, 0.